In this video, the topic to be discussed is passive infrared sensor, PIR. Passive infrared sensor. PIR sensor or PIR motion sensor, both are same, is the kind of infrared, that means IR sensor, that measures the infrared radiations released from the object. Here, person and animal are acts as objects. These two are living things. Any living things having some temperature. These living things emits some radiations like that. The IR sensor. This is the IR sensor. IR sensor that measures the radiations. These are the radiations released from these two objects, and thus identify them as moving or still objects. These two objects must be is in moving condition only. Then only this PIR motion sensor measure the infrared radiations releasing from these two objects, living objects with moving condition. This type of motion sensor is only the receptor of infrared waves. This one is the receptor receiving the infrared radiations from living objects which are in moving condition, but not release any infrared beam like that. It is done in the active infrared sensors. Active infrared sensor release infrared beams. Infrared beam. Passive infrared sensors, acceptor, receptor. This type of motion sensor is only a receptor of infrared waves from the living object. Receive the infrared test. Receptor of infrared waves from the living object which are moving condition. PIR sensor works on the principle of scanning the nearby area and then responding to change in the temperature. This one is the PIR nearby area, scanning the nearby area and then responding to change in the temperature. The living objects are moving condition, therefore temperature is also changes. These changes are recognized by the PIR sensor. Next point here is summer. In hot weather condition, the temperature of the environment does not change too quickly, and hence there is no effect on the sensor. If the temperature on the object or living thing is not changed, but the sensor has no effect. But whenever a human comes into the detection range of the PIR sensor present in the same hot weather, this is the area. This one is the area censored by the PIR sensor. Whenever that 37 degrees centigrade, temperature of that area is 37 degrees centigrade, that the temperature of that environment does not change too quickly, and hence there is no effect. There is no effect on the sensor. But that means that the sensor cannot recognize these changes. Whenever a human comes into that detection region, in this region of the PIR sensors present in the same hot weather, there comes a quick change in the nearby environment, and thus the sensor comes into action. Whenever a living person moving and comes into that area, the temperature conditions changes. That's such type of actions are recognized by that PIR sensor. All the objects living this is having a temperature more than absolute temperature. Suppose all the objects like animals, persons, these are the living things having a temperature more than absolute temperature, minus 273 degrees centigrade, more than absolute temperature, emits infrared radiations in their surroundings. Warmer the object, more than infrared radiations are emitted. Suppose living things having some temperature more than absolute zero emit some infrared radiations. So such type of radiations are recognized by the sensor, PIR sensor. The PIR is a thermal infrared IR sensor which detects the motion of the objects on reading these infrared radiations. Variations in its nearby environment. Final one. Next one, Hcsr 501 PIR sensor pinout configuration. This is the pinout configuration. This sensor has a 3 pins, VCC and output pin, ground pin. VCC output and ground. This is the actual pins configuration. VCC is connected to Arduino board of VCC supply. Ground of that pin is also connected to ground of that Arduino board. And output, this is the output pin of the sensor is also connected to one of the digital pin of that Arduino board. This is the PIR, passive infrared sensor pins configuration. Pin configuration. Next one. Hcsr 501 PIR sensor is a sensor that can detect the motion of humans, animals. Movement is compulsory, either humans or animals. It is widely used to detect the presence of humans in many applications. In presence of humans in many applications, very, very important, because humans having some temperature, the humans are in moving condition, not are in a standstill condition. Due to that movement, some radiations are emitted. These radiations are recognized by the PIR sensor. It is also important application is automatically turning on off light bulb, opening, closing the door. Whenever a person come near to that door, the door is open. Whenever the person is entering into that one in the lift, that door is closed. Activating or deactivating escalator. Detecting an intruder. Whenever a faulty person came into your home with the help of that PIR sensor, that person is easily identified. These are some important applications. This sensor, this is the sensor detects motion based on the change of infrared radiation from the moving object. Change of infrared radiations from the moving object is very, very important. To be detected by the sensor, the object must meet two conditions. The object is moving or shaking, is emitting the infrared waves. Next one is suppose an object, this one is the object. Object is moving, not emitted infrared rays. Example, robot or vehicle, toy. These are the robot is moving but not living thing. Based on that artificial intelligence, the robot is working. That robot is also an object, but object is moving. Infrared radiations are not emitted. It is not detected by the PIR sensor. That is one important point. Second point here is if an object emits, this one is a person. The person having some temperature emits some infrared radiations. Okay, but it is not moving, moving. It is not detected by the sensor. That this object is not detected by the sensor. This object is also not detected by the sensor. Robot vehicle toys are not detected by the sensor because these objects are moving, but infrared radiations are not emitted. Humans and animals naturally emits the infrared radiations. Therefore, the sensor can detect the movement of humans and animals. Humans and animals having some inbuilt temperature, having greater than absolute temperature. These humans and animals are moving in condition. Some radiations are emitted. Uh, Such type of radiations are easily accepted by the PAR sensor. Next, when there is no human animals moving in the detected range of the sensor, this is the sensor, PAR sensor. This is the range. This one is the range. If there is no human or moving or animal moving in the detected range of sensor, the output pin is low. The PAR sensor are having 3 pins. This is VCC output pin. This one is ground. Okay, the output pin is low. An object, living object, is not there in the area, sensing area of that PAR sensor. Therefore, the sensor pin is low. When human or animal moving into the detected range, person is entered into that detected range of the sensor, the output pin of the sensor is changed from low to high. Whenever a living person or animal having some temperature entering into that range of the sensor pin goes from changed from low to high. When there is a human or animal going away from the sensor, detected range of the sensor, the output pin of sensor is changed from high to low. Changed from high to low. These are the some. Therefore, we have to choose sensor pin is high. Have to recognize something. If the sensor pin is value is low, recognize something. Recognize something means cannot detect. Object is not detected. Okay, these are the important. These are the points are very important. Coming to in our experiment, LCD, LED, and serial monitor. Serial monitor importance is more. LED means whenever if the sensor pin value is very high, you have to set some actions. That means LED is on. LED is on, and on that LCD screen indicated that object is recognized. Object is recognized. In the serial monitor, 1 is there. In the serial monitor, 1. That means high value. High value. High value. LED is on. Yeah, and that LCD object is recognized. That person moving away from the sensing region, that means the sensor pin value changes from high to low. That means low value. The LED is off. On that LCD, that person object is not recognized. In the serial monitor, that value is 0. This is the main idea behind that PAR sensor action. This one is ground, VCC, contrast control, register select, read write, enable. One important point here is you have to make some connections between this is the liquid crystal LCD. Liquid crystal LCD. These are the Arduino pins 13, Arduino 13, 12, 11, 10, 9, 8. These are the some Arduino pins. This pin of that LCD is connected to ground. 5 volts is connected to 5 volts of that Arduino board. This is the contrast control. Next one is contrast control. In this program, instead of a potentiometer, the contrast control pin of that LCD is connected to pulse width modulation, one of the pulse width modulation pins of the Arduino board. 6 pulse width modulated pins are there in the Arduino board. Out of that 6, one pin you must select. That pin is sixth pulse width modulation pin you choose on the from the Arduino board. 6th pulse width modulation pin. Instead of potentiometer, here we use analog right. Analog right. 6th pin, some value. Analog right means some value 0 to 255. Here we use 90. This is the contrast value. C1TRA. The contrast value is defined at the beginning of the program. Later we will see these conditions. Okay, ground. First pin is connected to ground. Second pin is connected to 5 volts. These two are made on the breadboard from the UNO board. Contrast control pin is contrast control is connected to 6th pin. 6th pin of that Arduino. Next, resistor select is connected. This is the resistor select is connected 13th pin of that Arduino. 13th digital pin of that Arduino board. Next, read write. Read write pin is connected to ground. Enable pin is connected to 12th pin of that Arduino board. Data pins D0, D1, D2, D3. These are the data pins are not connected. Leaving these data pins, D4, D5, D6, D7 are connected to 11th, 10th, 9th, and 8th digital pins of the Arduino board. D4, D5, D6, and D7. Next, these are the LED. This one is LED connected to 5 volts through some resistance. These are the 2 pins connected to 5 volt through resistance. This one is ground. These are the some important standard connections we have to made in between LCD screen and UNO Arduino board. See the connections. These are the connections. And LED is also whenever an object, living object having some temperature enter into that sensing region of that PAR sensor. Therefore, sensor pin is high. LED is on. LED is on. In that screen, on that screen, the object is recognized. Object is recognized. The object is recognized. Okay, next one, another important is in the serial monitor, value indication is 1. Okay, whenever a person or animals are leaving away from the region, the sensor pin is low. That means 0. Object is not recognized. Object is not recognized. Object is not recognized. These are the things. These are the 2 important things. Okay. Now I will concentrate on programming. Here in that programming, we consider a pin of PIR sensor and LED anode and cathode pins. Next one, these are the important things to be considered for this program. Okay, definitely first statement is definitely we need some library for a liquid crystal LCD. This must included at the beginning of that program. / include less than like liquid crystal.h. Liquid crystal liquid crystal LCD 13, 12, 11, 10, 9, 8 means have to make connections between the Arduino board and the LCD screen. 13 means here this one is connected to register select pin of that LCD. 13th is the digital pin of the Arduino board connected to register select of the LCD. 12th pin is the enable pin. Enable pin of that LCD is connected to 12th pin of the Arduino board. 11th is connected to data pins D4, D5, and D6 and D7. These are the data pins of the LCD is connected to 11, 10, 9, 8 digital pins of the Arduino UNO board. Next, have to define sensor pin. Constant integer sensor pin. Third digital pin of UNO board. UNO. Next, LED pin. LED pin is also assigned fourth digital pin of the UNO board. Total the Arduino board having 0 to 13 digital pins. Some of the digital pins are assigned to LCD. Some of the pins are assigned to sensor pin and LED pin. Initially, the sensor state is 0. It does not sense anything. Whenever an object is entering into that plane, sense the condition only. Okay. Next, here two contrasts are there. Next, integer contrast, because in LCD contrast pin is also there. Instead of using a potentiometer, that pin is the pin connection is indicated in the code. Now we will see this one. These are the declaration. These are the declarations. Next, coming to in the void setup, here LCD plus LED action plus serial monitor. These three are very, very important. These three actions are included in the form of programs. These three devices. Okay. Next, initially, first one LCD. LCD is clear. Screen is clear by using this one. LCD begin with LCD dot begin 16,2 means 16 columns and 2 rows. 16 columns and 2 rows. Next, serial. These two are belongs to for LCD. Serial begin data rate. This one belongs to serial monitor. Okay. Pin mode. Sensor pin. Declaration of the sensor pin is the input pin. Pin mode LED pin is the output. LED pin means anode. Pin mode sensor pin is input. Pin mode LED pin is the output. Analog write 6,5. Analog write 6,5 means this is the this one some here we use some value 90. The contrast pin of that LCD is connected to pulse width modulated pin, that is a 6th pin of that Arduino board. Okay, here we indicate some values. Based on that values, the contrast of that LCD screen changes. Instead of potentiometer, instead of that potentiometer, just write this one. the contrast value changes. Delay is 100 milliseconds. In the void setup, these are the things are discussed. Next one. In the void loop, action criteria. Whenever a person, okay, here initially sensor, this one is sensor. The sensor state is 0. Initially the sensor state is 0. This is the area. Infrared radiations are not recognized. Sensor state here digital rate. Why? Because the sensor pin is connected to one of the digital pin of the Arduino board. That is the reason we use digital rate sensor pin. Serial dot print line sensor state. Sensor state means either high value. Sensor pin is at high or at low. That is the sensor state. If the sensor state is high means object is recognized. Okay, digital write LED pin, the LED is on. If the sensor state is high means the pin is at high condition, higher value. That means object is entered into the region, sensing region. At that instant, the LED pin is on. Digital write LED pin is high. LCD dot set cursor 00 first row first column. LCD dot print object is found. LCD dot set cursor 01. LCD dot print the LED is on. These are the things, actions related to the sensor state is high. Next one, else. No need to write here. Else, digital write. Else means the sensor state is low. That means object is moving away from the region. Digital write. The LED pin is low. That means LED is an off condition. Again, LCD dot set cursor 00 first row first column. LCD print. LCD dot print object is not found. LCD dot set cursor 01. That means second row first column. LCD print the LED is off. These are the declarations, actions of that this project. These are the important. This is the connectivity. By using these pins, digital pins of that Arduino board, we have to make the connections between this Arduino board and LCD. This one is a PIR sensor, 3 pins. Here 3 pins. One is VCC, another one is ground. These two are connected here, and one of the pin of that LCD is assigned to digital pin of the one of the pin of that PIR sensor is assigned to digital pin of that Arduino board. Totally, we use digital pins of that Arduino board and the pins of that PIR sensor and the pins of that LCD screen. We have to make the connectivity between these 3 devices. Okay, now I will concentrate on this one is demonstration by using this one. This one is a ground pin, power pin, contrast pin is connected to. This is the contrast pin. Power. This one is contrast pin is connected to 6th pin. This is the 6th pin. 6th pin of that Arduino board. Next contrast pin is power. Next register select. Register select pin is connected to 13th pin. Read write pin. Next one is read write pin. This is the read write. The read write pin is connected to ground. Enable pin. This one is enable pin is connected to 12. After that DB0, DB1, DB2, DB3 is not used. DB4 is connected to 11. DB5 is connected to 10. DB6 is connected to 9. This one is DB7 is connected to 8. Next, coming to this one, LED anode is connected to supply through resistor. Cathode is connected to ground. In the software, that PIR sensor has 3 pins: signal pin, power pin, and ground pin. In that one, the indication is like that. In some cases, this one is VCC, this one is ground, middle pin is a signal pin. Here, actually pins are different. Declaration is different. This one is the signal pin. Signal pin is assigned to third pin. The signal pin is assigned to third pin of the Arduino board. The remaining 2 are connected to VCC and ground pin. Next, one more here is this one is LED cathode. LED cathode is connected to ground through resistance. LED anode is connected to one of the digital pin. That is the fourth one. Third pin is assigned to third pin of the Arduino board is assigned to PIR signal pin. Fourth pin of the Arduino board is assigned to anode of the LED. Now we will see the demonstration. When LED is on, that object is recognized. When LED is off, the object is not recognized. These are the already I have explained code clearly. I am no need. I am not explain again. That start simulation. Start simulation. Object is not found. Here, object is not found. LED is off. Object is found. LED is on. Object is found means that living object having some temperature is entering into that sensing region of that PIR sensor. At that instant, the object is found. LED is on. Here, object is found. The LED is on. Here, object is found. The LED is on. Here, object is not found. The LED is off. The object is not found. LED is not off. Object is must be in moving condition only. Object is must be in moving condition. This one is the simulation related to that project. This is the code. This is the code of that this project. With this software demonstration completed. Next one, hardware demonstration. This one in hardware, I have made connections between this LCD board and this one is LED. This one is LCD. LED is on and the UNO board. And the UNO board. This one is the PIR sensor. This one is PIR sensor. LED is on means object is recognized. The object is found. The LED is on. If the LED is off means the object is not recognized. Demonstration of PIR sensor with Arduino using Tinkercad. This is the code. By using here LED, LCD, PIR. LED has 2 pins, anode pin and the cathode pin. Anode pin is connected to one of the digital pins of the Arduino board. Cathode is connected to ground through resistance. This one is cathode. This PIR sensor has 3 pins: signal, VCC, power and ground. The signal pin is connected to one of the digital pin of that Arduino boards. These are the 16 pins of that LCD. The 16 pins, out of that 16 pins, this is the ground pin is connected to ground, VCC, power pin. Contrast pin is connected to 6th pin of the Arduino. That must be PW, pulse width modulation pin. Register select is connected to one of the pin of the Arduino. Read write is connected to ground. Enable pin is connected to one of the pins of the Arduino, digital pin of the Arduino. DB0, DB1, DB2, DB3 is not connected. DB4, DB5, DB6 and DB7 are the data pins of the LCD is connected to digital pins of the Arduino. LED is connected to LED anode is connected to 5 volts through resistance. This one LED is connected, LED cathode is connected directly connected to ground. This one is LED cathode. This one is LED anode. These are the connections. Next one. This one code already explained. This is the code of that PAR sensor interfacing with the Arduino. Start simulation. This one is here. Serial monitor. Serial in that serial monitor, the state of that pin, PAR sensor pin is low. The LED is off. Object is not found. Object is not found. Suppose whenever this is the sensing region, whenever object is entered, okay. Enter into that sensing region. The pin state is PAR sensor pin state is at high condition. That means 1 indicated here. 1 here indicated here. The LED is on. Object is found. The LED is on. The object is found. The object is not found. The object is found. The object is not found. Zeros. All are zeros. The LED is off. If object is found, here ones are there. State the pin state is at PAR sensor pin state is at high. Object is found. The LED is on. This is the demonstration of that Arduino with PAR motion sensor in Tinkercad. If you like this video, please subscribe the channel for further updates. Thank you.